So now step 3 is nothing but computation of first and follow function. Now we have to calculate first and follow function for every non-terminal. Now how to calculate first and follow we have seen in the last concept. Now I'll just write, once you have done with first and follow for every non-terminal, you just maintain a table like this. The first column is nothing but non-terminal, second column is nothing but first, last one is nothing but follow. So how many non-terminals we have? 6 non-terminals. First one is A, next one is SA, first one is SA, next one is B, C, D, E. Now we'll just write down the results we got in the last problem. So because we have taken the same problem, A, B, C, first of A we got A comma epsilon, first of B we got B comma epsilon, next one we got C, next one we got T comma epsilon, next one we got E comma epsilon. Follow we got follow of S is nothing but dollar, next one we got B comma C, next one we got C, next one we got D, next one we got E, last one we got dollar. So these are the results we got in the previous problem. Now next one is step 4. Now once we are done with computation of first and follow function step, then we can move on to the next step. Step 4 is nothing but predictive parsing table. So where predictive parsing table is nothing but, where table is nothing but set of rows and columns, where rows are nothing but non-terminals, where columns are nothing but terminals, terminals. Now first you just construct a table. How many non-terminals we have? First one is A, S, B, C, D, E. Next one we got next one, columns are nothing but terminals, that is A, B, C, D, E, dollar. We have to add dollar to the terminal set. So parsing table is nothing but set of rows and columns, where rows are nothing but non-terminals, columns are nothing but terminals, including dollar, where dollar is nothing but end marker, which tells the parser that is end of string. Now how to fill these entries in the table? Now first consider the first production rule, that is S tends to A, B, C, D, E. We just compare this production rule with A tends to alpha. If alpha is not equal to epsilon, for example, if alpha is not equal to epsilon is nothing but, then we have to calculate first of alpha, where first of alpha is nothing but first of A, B, C, D, E. First of A, B, C, D, E. First of A, B, C, D is nothing but first of A. What is first of A? Where first of A is nothing but A comma epsilon. So A comma, substitute epsilon in A. We have seen this procedure in last problem. Substitute epsilon in A. What you will get? First of B, C, D, E. First of B, C, D, E. So what is first of B, C, D, E? First of B. So what is first of B? It is B comma epsilon. So B comma, substitute epsilon here. What you will get? First of C, D, E. So what is first of C, D, E? First of C, D is nothing but first of C. So first of C is nothing but small c. So A comma B comma C. So I am just repeating again. First take the production rule S tends to A, B, C, D, E. Compare this production rule with A tends to alpha. If alpha is nothing but epsilon, that is, if alpha contains at least one symbol, RHS contains at least one symbol, then calculate first of it. First of alpha is nothing but first of A, B, C, D. After substituting epsilons and all, we got A comma B comma C. Now, so how to fill those entries? So we have calculated for S tends to A, B, C, D. What is LHS symbol? Yes. Now go to this row, S row. Now under terminal symbols A, B, C, you just write down that production rule. S tends to A, B, C, D, E. Under B, S tends to A, B, C, D, E. Under C, S tends to A, B, C, D, E. Now, so we are done with first production rule. Now coming to next production rule. The second production rule is nothing but A tends to A. Compare this production rule with A tends to alpha, where alpha is not equal to epsilon. Then you have to then you can calculate first of alpha, where first of alpha is nothing but first of small a, where a is terminal symbol. So first of alpha is nothing but a. Now a tends to a. Go to a non-terminal row. Under a we have to write a tends to a. Now third production rule is nothing but a tends to epsilon. Epsilon. Compare this with a tends to alpha, where alpha is nothing but epsilon. Therefore we have to calculate follow of LHS variable. Follow of LHS variable. What is LHS variable? It is follow of a. Now follow of a, we have already seen follow of a, where follow of a is nothing but b comma c. We have seen in the last step, that is b comma c. Now under b comma c we have to write a tends to epsilon. Under c we have to write a tends to epsilon. Epsilon. Now go to next production rule. What is the next production rule we have? B tends to b, where b tends to b is nothing but, compare this with a tends to alpha, where alpha is not equal to epsilon. So therefore first of alpha is nothing but, so if it is not equal to epsilon, calculate first of RHS part. If it is if alpha is epsilon, calculate follow of LHS part, that is LHS variable. Alpha is nothing but b, where first of b is nothing but small b. So go to b row. Under b we have to write b tends to b. Now go to next production rule, that is b tends to epsilon. Compare this with a tends to alpha, where alpha is nothing but epsilon. So therefore we have to calculate, if alpha is epsilon we have to go for LHS, that is follow of LHS variable, that is follow of b, where follow of b is nothing but, so we have seen follow of b in the last step. So where follow of b is nothing but c we got, so c. So go to this b row, we got c non-terminal. Under c we have to write down b tends to epsilon. Now we will just move on to next production rule, that is c tends to small c. Compare this with a tends to alpha, where alpha contains one symbol, that is alpha is not equal to epsilon. So therefore we have to calculate first of alpha, where first of alpha is nothing but first of c, small c, that is c. So go to this c row, capital C row, non-terminal row. Under c we have to write down c into c. Next one, d tends to d, a tends to alpha. First of alpha is nothing but first of d. First of d is nothing but d. So under d we have to write d tends to d. Now last one, e tends to small e. First of alpha, where first of alpha is nothing but first of small e. First of small e is nothing but e. So under e we got e tends to e. E tends to small e. So we have done with all production rules. Now blank entries will be marked with error. You just mark error. So that means whenever we got s comma small e, that is error. So therefore the given grammar is L1 grammar. Why I can say the given grammar is L1 grammar, I will tell you. The given grammar is, so no, we have done with top down parsing techniques, that is L1 parsing, step 1, step 2, step 3, step 4. So step 4 we have seen, that is construction of parsing table. So if they want to implement using stack, you can take input string and you can implement by using stack, by using the read to parsing table. Now we'll just move on to bottom up parsing techniques. There are three types of bottom up parsing techniques. The first one is operator precedence grammar. So it is something like you will be having precedence relations, less than relation, greater than relation, equal relation.
This video is brought to you by Monster Shakes, co-sponsored by TechnoSpark.
Precedence relation. Now second one is shift reduce parser. Shift reduce parser is nothing but bottom up parsing technique, that it will construct parse tree from leaf node to root node. You will be having input string and you have to end up with the stat symbol, that is root node. And there are 4 operations we have in shift reduce parser. The first one is shift, second one is reduce, third one is accept, fourth one is error. So shift is nothing but shifting the symbols from input buffer to the stack. Reduce is nothing but whenever we have handle is nothing but the RHS part. Whenever we have RHS part, it will be reduced to LHS variable. Now third one is accept. $1 is nothing but accept, or $$ is nothing but accept, or $E in the $start symbol. Let me take E as start symbol in the stack, and $, in the input string, or that is input buffer, it is nothing but accept. Now fourth one is error. When we are in a situation where we can't able to perform shift or reduce or accept operation, is called as error operation. Now third one is LR parser. I have already told that LR is nothing but, L is nothing but left to right scanning, R is nothing but reverse of RMD, rightmost derivation. There are 4 LR parsers we have. The first one is LR of 0, next one is SLR of 1, third one is CLR of 1, fourth one is LR of 1. Now I am going to discuss these 4 types of parsers. You just remember one thing. For the first 2 parsers, we have to consider LR of 0 items. For the next 2 parsers, we have to consider LR of 1 items. Now I'll just start how to construct SLR of 1 parser. Construction of SLR of 1 parser. Construction of SLR of 1 parser. So SLR of 1 is nothing but, where S is nothing but simple and L is nothing but left to right scanning, that is direction from left to right. R is nothing but reverse of RMD, where RMD is nothing but rightmost derivation, where 1 is nothing but 1 locate symbol. What is locate symbol? Current symbol in the input buffer, current processing symbol in the input buffer. So now I am going to construct SLR of 1 parser for the given grammar. So where G is the given grammar, where G is nothing but context free grammar. So we have 3 production rules. S tends to AA, where capital A tends to small a, capital A tends to B. So where we have 2 non-terminals, S comma A, and 2 terminal symbols A, B. Now we have to consider G dash, where G dash is nothing but augmented grammar, where G dash is nothing but augmented grammar. So augmented grammar in the sense, we have to consider the start symbol. What is start symbol? S. S dash tends to capital S. If it is E dash tends to capital E. S dash tends to S. Now write down the production rules of S. What is S? AA. So what is the production rules of A? It is small a, capital A. Next one is capital A tends to small b. Now first one is step 1. I have already told that for LR of 0 and SLR of 1, we have to consider the LR of 0 items. So canonical collection of LR of 0 items. So what is LR of 0? Let me take production rule like this. If A tends to ABB, this is called as production rule. Now what is LR of 0 items? If you find dot anywhere in RHS, for example A tends to some dot ABB or A tends to A dot BB. If you find dot operator anywhere in RHS, is called as LR of 0 item. So production rule is like alpha tends to beta. If you find dot operator anywhere in RHS, is nothing but LR of 0 item. Now first one, you just consider first item set, that is I0, where I0 is nothing but S dash tends to dot S. You just place dot operator right after the arrow mark initially, dot S. After dot, you just observe the symbol. If the symbol is terminal symbol, no need to do anything. If it is non-terminal symbol, we have to write down the production rules of that non-terminal. Dot S, where S is nothing but what? Non-terminal. Now write down the production rules of S. That means S tends to AA. While writing the production rules, we have to place dot operator right after the arrow mark initially. Dot. Next one. So we are done with writing production rules of S. Now S tends to dot AA. Dot A is nothing but non-terminal. So that is A tends to dot AA. Now A tends to dot B. So for A we have written two production rules, A tends to dot A tends to dot B. I have already told that while writing production rules we have to place dot operator initially like right after the arrow mark. So dot small a, no production rules, dot small b, no production rules. This is I naught. Next one is I1, where I1 is nothing but, now we have dot s, dot a, dot small a, dot b. So go to of I naught comma capital S, I naught comma capital S. That means what? You just observe dot s conditions in dot s production rules in I naught set. So dot s, we have only one dot s. You just move this dot operator one step forward. That means what? S dash tends to s dot, s dot. So we are done with this production rule. Next one, go to of, now what is the next one? Dot a, go to of I naught comma capital A. So I naught comma capital A, dot a we have only one. If we have two production rules like dot a, we have to move dot operator one step forward for both the production rules. So we have dot a for only one production rule. What is that? So that is nothing but s tends to a dot a. So dot a is there. Write down the production rules of a, that is a tends to dot a. Now a tends to dot b, dot b. So this is nothing but I2. So we are done with this. Now next production rule, next one is nothing but go to of I naught comma small a, that is this one, a tends to a dot a. Dot a is nothing but terminal, non-terminal. We have to write down the production rules of a. Dot a tends to dot b, a tends to dot b. That means what? Go to of I naught comma b, I naught comma a is nothing but I3. So we are done with this. Next one, go to of I naught comma small b, where I naught comma small b is nothing but a tends to b dot. So what is the production rule? I4. So we are done with I naught. Next one, I1. So regarding I1 we have only one production rule, s dash tends to s dot. So dot came completely at the end of the RHS part, no need to consider this. Now coming to I2. So coming to I2, go to of I2 comma, so we have three situations, dot a, dot small a, dot b. So I2 comma capital A. What is I2 comma capital A? Capital A is nothing but s tends to a dot, s tends to a dot. So this is nothing but I5. So we are done with this. Next one, go to of I2 comma small a. So go to of I2 comma small a is nothing but a tends to a dot capital A. So dot a is nothing but a tends to dot a tends to dot b. So these are the same production rules we got in item set 3. So that's why name it as I3. If same production rules are repeated when compared to previous item sets, you just take the same item set number. Next one. So we are done with dot a. The next one is go to of I2 comma small b, that is a tends to b dot. So where a tends to b dot. So here we got a tends to b dot. That means what? This is nothing but I4. So we are done with this. Next one, I3. So where I3 is nothing but go to of I3 comma capital A, where I3 comma capital A is nothing but a tends to a dot. So that is nothing but we have ended with I5. Next one is I6. So this is done. Next one, go to of I3 comma small a. Go to of I3 comma small a is nothing but a tends to a dot capital A, that is nothing but I3. I3 comma is nothing but I3. Next one, I go to of I3 comma small b, that is nothing but a tends to b dot. A tends to b dot is nothing but I4. So we are done with this. Next, I4. So we have only one production rule in this. Now dot is moved completely at the end of RHS part. So no need to consider this. So here also dot is present at the end of RHS. No need to consider this. Next one, go to of I3 comma capital A. I3 comma capital A is nothing but what? This is I6. This is I6. So we already calculated. Next one, go to of, this is I6. Go to of I3 comma small a. So this we have already calculated. Go to of I3 comma b. This we have already calculated. Now coming to I4, A tends to B, this we have already calculated, this we have already calculated. So totally we got I0 to I6. So we have done with step 1, canonical collection of LR of 0 items. So we got 0 to 6. So total we got 7 states, where I is nothing but item. Item set 0 to item 6, item set 6. So totally we got 0 to 6 means 7. Now step 2. Step 2 is nothing but parsing table. A table consists of 3 columns. The first one is state, second one is action, third one is go to. So state is nothing but how many states we got? 7 states starting from 0. So 0, 1, 2, 3, 4, 5, 6. Now coming to action, where action is nothing but all terminal symbols. So what are the terminal symbols we got? First one is B, next one is small b, next one is dollar. Now go to is nothing but what? All non-terminal symbols, that is capital S and capital A. Capital S and capital A. Capital A. Capital S and capital A. So parsing table consists of 3 columns. Parsing table consists of 3 columns. First one is state. So there are 6-7 states we got. Next one is action. Next one is go to. Next one is
this video is brought to you by
7 states we got. Where action is nothing but terminal symbols. Go to is nothing but
sponsored by
non-terminal symbols. Now here you just remember 3 points. 3 points. The first one, 1 comma dollar is nothing but accept. So why 1 comma dollar is accept is nothing but, so where 1 is nothing but what? I1. I1 is nothing but what? S dash tends to S dot. So what is the objective behind this moving dot operator one step forward in the sense? So you just see this production rule, S tends to capital A dot capital A. So initially it is S tends to dot AA. So dot is placed right after the arrow mark. That means what? I didn't process this symbol and this symbol. Now in I2, dot is moved one step forward, that is S tends to A dot A, that is this symbol is processed, that is I have seen this A. In the next one, S tends to AA dot, dot is moved completely at the end of RHS, that is this AA, entire A is processed completely, like that. S dash tends to S dot. So dot is placed at the end of RHS in the sense I have seen S. Seeing S in the sense where S is nothing but what? Start symbol. So we have to start with input string, that is terminal symbols, and I have seen S in the sense we are done with parsing process, that is accept. So that means what? It's a bottom up parsing. We have to start with input string, we have to end with start symbol. S dash tends to S dot in the sense in the I1 we can, in the I1 item set we can see that S. Seeing S in the sense I am done with parsing process, that is $1 is nothing but accept. Now next one is how to fill shift operation, how to fill reduce operations. So $1. So $1 is nothing but accept. So why $1 we accept in the sense S tends to S dot. S dot in the sense S is completely processed. So I have seen that yes, start symbol. Now next one, shift operations. Now first one is 0 comma S. So where S is nothing but non-terminal. Non-terminal since we have to fill in the go to tab, go to area. Now if it is terminal symbols we have to fill in action area. So 0 comma S is nothing but 1. So 0 S is nothing but 1. So if it is non-terminal we have to write down the state number only. Don't add S to go to part. Next one 0 comma A. A is nothing but non-terminal. So this is 2. Next one 0 comma small a. It is terminal symbol. So 0 comma A is nothing but S3. For terminal symbols we have to write down the next state number, that is 3. Along with that S is nothing but shift operation. Next 0 comma B is nothing but 4. 2 comma A is nothing but 5. Next 2 comma small a is nothing but 3. Small a is nothing but 3. Next 2 comma small b is nothing but S4. Next 3 comma a is nothing but I6. I6 is nothing but 6. Next one 3 comma a is nothing but 3, that is S3. Next one 3 comma b is nothing but S4. Next one 3 comma b is S1. Next one 3 comma capital A is nothing but 6, that we have already done. Next one I4. So this is nothing but shift operations. Next one reduce operations. Now what is reduce operations? You just search for every item set in such a way that whether you got a production rule is in the form of A tends to alpha dot or not, A tends to alpha dot or not. So first one I naught, we don't have any production rule in the form of A tends to alpha dot, dot must be completely at the end of RHS part. S tends to S dot, we have already written $1, so no need to consider this. Next one, in the I4, we have one production rule in the form of A tends to B dot, that is A tends to alpha dot. So A tends to B dot, A tends to B dot is nothing but A tends to B dot. So in which item set we got this? We got this in I4 item set, I4, A tends to alpha dot. So we have to calculate follow of A. So where follow of A is nothing but, what is follow of A? So what are production rules we have? S tends to A tends to A capital A tends to B. So what is follow of A? Where follow of A is nothing but.
For more updates, stay tuned to KL Radio, the voice of Kalians. This video is brought to you by Monster Shakes, co-sponsored by TechnoSpark.